So teacher demonstrated some features of waves using the ripple tank. The figure below shows the ripple tank. So this is a wave that is created in a ripple tank. It's in a water. So this is the wave in liquid. So they have a vibrating bar that is creating the wavefront, and they have a water. It's 5 millimeter thickness depth. That is easier for us to observe the wavelength or wavefront. Most of the time is 5 millimeter thickness depth. The teacher measured the time taken for 10 wavefronts to pass the mark. So teacher repeated this measurement 3 times and calculated the mean in order to reduce the random error. So what is the advantage of repeating measurement and calculating a mean? So that will reduce the random error. Okay. The teacher measurements for the time taken for 10 wavefront to pass the mark were 84 seconds, 7.8, so 8.4 seconds, 7.8 seconds, 8.1 seconds. Calculate the mean frequency of the wave. Okay, it is a tricky question. So they are giving you a time period. So the time period for the 10 whole wave cycle. So time period is the amount of time taken for a whole oscillation of full wave. So they have counted for 10 waves. So 10 t is equal to 8.4 at 7.8 at 8.1 divided by 3. That will be, if you do that calculation, you should get 8.1 second. That is for 10 time period. So one time period is equal to 8.1 second divided by 10, because they found the time period for 10 wavelength. So that is 0.81 seconds. And then another equation you need to remember is time period is equal to 1 over frequency. So the frequency f is equal to 1 over t. That means 1 over 0.81 second. That should give you an answer of 1.2345, but they have given us the answer in significant figures. So make sure don't lose marks on the significant figures. So most of the time they sneakily ask the significant figures, so you need to make sure you're not losing marks on that. Okay. In a different investigation, the teacher wanted to determine the speed of water waves in a ripple tank. The teacher did not measure the wavelength. So teacher did not measure the wavelength. Explain how the teacher could determine the speed of the wave. So how can C measure the speed of the wave? Okay, what she can do, so normally we use V is equal to F times lambda, but unfortunately she hasn't take the reading for our lambda, so she didn't get it. So how else can we get wave speed? So velocity or speed is equal to distance divided by time. So it is our usual equation, isn't it? So for that, what we can do is we can measure from set distance using a meter ruler. Let's say this one. And the wavefront start coming here, we can start the timer. When it reaches here, we can stop the timer. So we can measure the distance using a meter ruler. We can time it for the time it takes for the wave to travel from here to here. Hence, we can use that in this equation. So measure a set distance in the ripple tank using a meter ruler. And then time the measure the time it takes for the wave to travel that distance using a timer, and calculate the speed using speed is equal to distance divided by time.